Hello, and welcome to 5-Minute Math. Today we are looking at activities to teach the Algebra 1 standard A.5C, solving systems for two linear equations with two variables. So this is a blog post off my website, 5minutemath.net, and I will put a link to this post in the video description. So this post starts with some teaching videos here, how we can solve mathematical systems of equations, and then real-world systems of equations. So those are just some teaching videos there. And the reason I'm doing this video is because we have some star performance recently that shows that we struggled with this. This is 2023 star Algebra 1. You see on this particular problem, number 23, the state of Texas did okay, 68%. That's actually pretty good. Here's a video showing how to explain it. It was this one, number 40. Take a look at that, 31%. It's a system of linear equations, but there's nothing really in the verbal description here that says this is a system of linear equations. There's not even any variables provided. You have to interpret this real-world situation with the table as a system of linear equations. Once you do that, it's not that hard to solve, but the problem is recognizing it. So students need a little bit more practice on recognizing real-world systems of linear equations. All of the activities that I provide here follow this basic principle of active, playful learning. We want all of our learning to be active and meaningful, engaging, social, joyful, because when kids have fun, they learn more. You can learn more about active, playful learning with this link here. This particular video I'm making is going to go right here in this blog post, so let's start looking at our 5 activities. The first one is called Scavenger Hunt. And so we simply want students to solve systems of linear equations. The systems of linear equations are going to be called out, and we want it to be fun. So you want to divide the class into 9 teams. You're going to select 9 different locations around the school that you want to place these systems of linear equations. I have an example here. I'll put on the screen here. So here's the recording sheet for the students. And what you're going to do is, I've got some examples here. I just picked some locations. Obviously, you can make a copy of this Google Doc and you can change it. But here are some uh, two linear equations here. And what you want students to do is solve, right? And put the solution here, the x and the y. And then they're going to put whatever that next location is in this solution coordinate. So the outside front office is where they're going next after they solve this. So wherever they solve this, they're going to put it in this table up here. So I have 9 different problems here, and you'll see the answers here, right? So here's an example. So this first one I was showing you, the solution is x equals 1, y equals 1. So they're going to put outside front office right here in this. I think of it like a, like a grid here in this x equals 1, y equals 1. Then they're going to go to the outside front office and they're going to get this system right here. And the solution is going to be x of 2, y 1. And that next location they're going to is teacher's desk. So they're going to put the next location in the x of 2, y of 1. And then they're going to go around. You get to change the coordinates, but obviously the kids are just walking around having fun. They want to know where to go next. So that's basically it. You can adjust the number of locations and the systems of linear equations to meet your needs. So you might need 6 locations rather than 9. Uh, this particular grid, I wanted to create it so that the x and the y values were shared here, but you don't necessarily need to have it like that. You can just create 9 different rows, and each row can have its own unique system that has its own unique solution. So that would work as well. For extra credit, extra support, rather, if you want, you could put a QR code at each location that could share the solution, but you would want students to only use it if needed. And then you can give them the opportunity to create systems of linear equations and give them a target solution. So give a group a system of linear equations target solution of, let's say, x equals 3, y equals 4. See if they can come up with a system of linear equations that come up with that solution of x equals 3 and y equals 4. Our next activity is Desmos tic-tac-toe. And so what you're wanting to do is you're wanting to open up a graph on Desmos. You want to click on the settings, right? And the settings here is going to be that little wrench icon right there. So if I were to do it on Desmos, it'd be that little wrench icon right there. What you want to do is you want to change the x and the y axis to make it look like a specific thing. So the x axis, right, we want x to be greater than or equal to 0, less than or equal to 9. You want to change the step to 3. So we would do that right here. We would put that 0 right there. You would put a 9 right there, and you would make the step of 3. Then we do the same thing with the y, but I just chose different numbers. Y is less than or equal to 3, greater than or equal to -6, also with a step of 3. And what you're going to see here is you get, especially with that step of 3, look what you get. You get a little tic-tac-toe board. And so you are going to split the class into teams. They're going to play tic-tac-toe. Now, this is a little bit more difficult, so you want to give them a little bit more time. It might be an extended game of tic-tac-toe in which you play just a little bit each day and it lasts throughout the week. But what each team is going to do is they are going to come up with a set of linear equations, and the solution needs to be in one of these 9 squares, these larger 9 squares, right? And you see the x and the y values right here, but I can put solutions here. I've got 4 options, these 4 right here. You're not necessarily counting anything on the line. So right here, right, this is my y of 0. So if I have a y of 1 and an x of 1, it would land right there. What I need to do is I need to come up with a system of linear equations, and the solution is at that particular spot. So you see we're playing tic-tac-toe. So the green X's went first, and they had a solution down there, and that was at X of 1, and I believe that would be a Y of -1. And so that's theirs. And then the O's went there, and then the X's went there. And then the O's didn't block, they went up there, so the X's were able to make 3 in a row. And so it takes a little bit of time, but the kids will like it because if they can manipulate equations to come up with a specific solution. Basically, what we are asking for in this variation down here on the previous type of activity, then that's really high level stuff. So you might want to change the boundaries of the x and y axis to focus on moving the solution to different quadrants. In this case, I'm kind of in quadrant 1 and quadrant 4, but if you want everything to be negative, right, you can just kind of change these boundaries right here. That's going to kind of dictate uh, what type of solutions your kids are looking for. You can make each of the 9 quadrants smaller to create tighter areas. So I wanted to create 4 different landing spots for the students, but you can make them a little bit tighter with smaller ranges and smaller steps if you wanted to. You could place a time limit if you really think they're getting good at it. And this is one to where you're going to need to give a little bit of grace. If they get something on the line, it doesn't count. So if they were to have a solution of x of 3, right, and a y of 2, it would land right here, but it's gonna be on the line, so it doesn't really count. You might say your your only submission, it has to count, and if it's on the line, it just simply you just lose your turn. So that's Desmos tic-tac-toe. Our third activity here is DIY systems of linear equations. So you want to pair students up, you want to give them a copy of this Google Doc here, and then what you're wanting them to do is you're wanting to use a context from the third page, and I'll scroll down in just a moment to show you those. You want them to create their own story problem that includes a system of linear equations and then solves for one of the variables. Here are some examples from STAR, just for exemplars. So these are literally examples from STAR, and if sometimes students do a pretty good job if they are able to reverse engineer existing problems. So I didn't put the answer selections here, but these come from released STAR test questions that they can look at. So this is where they would actually create their story problem. So they need to go ahead and define what is their independent variable unit. Is it going to be hours? Is it going to be widgets? Is it going to be cars? What is their dependent variable unit? Write the problem right here. What's the solution? And then go ahead and write the value of both the independent and the dependent variable of the system of linear equations where that solution meets. And then here are the example contexts. So if they want to try without this, they can create their own problem. Sometimes they just don't know where to get started. And so here are some example contexts from mixing solutions, distant rate and time problems, budget and financial planning, scheduling and time management, production planning. There's 10 different examples here that they can use. These are simply the contexts. All they want to do is kind of tweak this into a few sentences, add some variables, and they should be good to go. Now, this is pretty high level stuff here because after they identify the units and they solve, they create the verbal description. That was the difficulty, remember, that we saw in this particular STAR problem, is the students were not able to recognize it's only 31%. And really, the other 3 answer selections almost had about that same amount, a little bit less. So that means most of the students in Texas were basically just guessing on this. If they could identify systems of linear equations in verbal description problems, once they set up the system, it's not that hard for most of these kids. The problem is identifying it. So that's what this particular activity is really honing in on, is creating your own system of linear equation verbal description, because if they can do that, they can identify it better on the STAR test. And so some variations are, you might want them to swap solutions with each other, obviously hiding the solution and solve. You might need to model how to create your own problem for the class as kind of a think aloud so they see how it's done. You might need to, for extra support, identify the variable units for the students. So literally all they need to do is create the constant values, put everything together. So they might not know that the dependent variable might need to be, the distance, and the, independent variable might need to be the time. So you might need to give those things for them. For extra points, you might allow students to add a table of values and a graph for the verbal description, and then save some of the better examples for an extra credit quiz. All right, our next activity is called Make a Table. And so what we're wanting to do here is we're wanting to simply see systems of linear equations in tabular form. So it's also kind of a hybrid callback here because this was part verbal description, part table. So you're going to come up with some verbal description star problems, and this goes straight back to what we just did, these examples from star. So start with these right here. And what you're wanting to do is having the kids create a table. So you want them to find the labels for the constants. You want to and create columns. You want them to find the categories of data, whether it be days, descriptors, and create rows for them, right? So take a look at this first one. Dance lessons were offered at two studios. Studio Q charges $30 registration fee and $80 a month. Studio R charges $105 registration fee plus $65 a month, right? So I'm envisioning two rows, Studio Q, Studio R, and different columns, right? One column for the registration fee, $30 and 105, another column for the monthly fee, $80 and 65 months. So what you're doing is you're wanting them to turn that verbal description problem into this right here. Because if you read this problem from the 2023 test, all the values were given in the table. They weren't written in the verbal description. And that's the first time we've ever seen a star question like that. Most of the time, the star questions are like this. It's just straight system of linear equations. They give you the linear equations you simply need to solve, or they actually are verbal descriptions and they ask you a question, but you have to kind of deduce what the linear equations are from the verbal description. This last STAR test in 2023 was the first time we really saw it in this hybrid form, part verbal description, part table. So that's what this activity is asking students to do, is simply, that's all they need to do, right? Take one of these problems, create a table. Then after they do that, they are going to need to add a few sentences to the text of the problem describing the table, right? So each website charges a different amount based on the number of clicks in the advertisement. The table shows the number of clicks on each website and the total cost for each of the 2 days. That's what we have from this particular STAR problem. Because what we don't do is just give them a table and say, go for it. You have to provide enough of a context for them to understand this is a system of linear equations. So they might need to add one or two sentences describing the table. And then you can rewrite the verbal description star problem into a tabular system of linear equation problem. And then that's it. That's the main activity here, is to have students rewrite it, because the idea of having to analyze it and create it is just going to, once again, make it easier for them to recognize it on the STAR test. So variations, you might need to convert one as a class, because some kids might get it and some kids might stare at you, not really sure what to do. You might need to provide the constant labels for students to use. You might want to have students exchange converted problems with a partner to solve. And then once again, save a few of the better conversions for an extra credit quiz. They love that. All right, finally, we are going to play game. It's called Graphing Challenge. All you need is graph paper. You're going to split the class into 2 or 3 teams. You're going to give systems of linear equations problems to students. And this one, you can use the ones from Scavenger Hunt. It doesn't it can be these right here. It doesn't need to be a verbal description, doesn't need to be a table. Just give them the raw systems of linear equations. But what you want them to do is you want them to graph them by hand. You want them to find the slope, find the y-intercept, graph the system. You want them to note the intersection, so they label the coordinates as a solution. And then all they simply do after that is you can use a graphing calculator, you can use Desmos. They, they simply check their work, but they do that afterwards. So you might want to give them a time limit and see how many they can do in that time. So that's the challenge, because on the STAR test, we want them using the calculator. But going through the process of identifying the slope, the y-intercept, how do you graph it by plugging, values back in, that's going to help students identify these systems linear equations and realize that they are graphs and that the solution is at the intersection of these two lines. You might want to give them, one problem at a time, and then as they show you one solution, you hand them the next one within a time limit. You might want to mix in some problems in tabular form, right? Because trying to identify the slope of the y-intercept is different when you're looking at this right here, right? Because with a little bit of work, you can easily get that in slope-intercept form. But how in the world do you get that into slope-intercept form? It takes an extra step or two. So that tabular form is going to make it look a little bit different. And then you might want to even mix in some word problems from verbal descriptions, right? If they can create a graph based simply on this, then that's the most work that they'll have to do, is to take all this and turn that into first equations, then finding the slope and the y-intercept. If they can do all that and graph it and find the solution, then using a calculator is going to be easy.